Alright, complex numbers. Now a complex number represented mostly by z is a number that can be expressed in the form a plus ib. From what we're able to see here, we have got two parts of a complex number. We have got this part which doesn't have I. This is called the real part. We have got the part which has got the I, which is called the imaginary part. This a itself and the b itself, these are real numbers. Now the I is what makes this a complex number. So this should tell you that at times this b can be a 0, right? So when b is a 0, 0 times I, that will give you 0, mean that z is just going to be equal to a. A can be any number, for example, a4, a5, a6, meaning that 6 itself is a complex number, right? 1 is a complex number. 0 is a complex number. What does this tell us? This tells us that all real numbers are complex numbers, but not all complex numbers are real numbers. As sometimes a complex number, I mean a real, so we are saying all real numbers are complex numbers. For example, 6 plus 4i, this one is a complex number but not a real number. We can talk about just 7. This one is a complex number also, but it is also a real number because the imaginary part is not there. So all real numbers are complex numbers, but not all complex numbers are real numbers. So that is something that we should be able to know and also get to differentiate. Now, because not all real numbers are complex numbers, for complex numbers, we can represent them on an Argand diagram, just like we can represent real numbers on a Cartesian plane. So an Argand diagram just shows the imaginary axis and the real axis instead of x and y. So this is the real axis, this is the imaginary axis. So if we have got a complex number z, which is, let's say, 4 plus 2i, it means that on the real axis we are going to have 4, on the imaginary axis we are going to have 2i. Now you will not see this I because by reason of this being with an I, it means it's already on the imaginary axis. So you just see it as a 2 like that. So this complex number is going to be somewhere here. This is going to be z. Let me call it z1. We can have z2, which is equal to 4. So if it is just 4, let me use a different number. Let's say it is negative 3. If it is just negative 3 like that, it means it's going to be here. That is going to be z2. We can have z3, let's say, which is just negative 3i. So you can see it has got an I. It means it's going to be here, right? It's going to be here. That is going to be z3. So this is how we are able to represent complex numbers on an Argand diagram. We can as well find the direction of complex numbers. For example, the complex number z1, which is 4 plus 2i, we can find this direction. So in this case, we need to join this to the origin like that. So the angle that this is going to make with the x-axis, that is the direction, and we call that as the argument. So if they say find the argument, all they are saying is find the direction of the complex number. So how do you find the argument? Argument, which is theta, is given as tan inverse of y over x, just like we know from vectors or projectile motion. So this will then be tan inverse being equal to y. Y is representing the imaginary axis. And so on the imaginary axis we have got 2. On the real axis we have got 4. You don't pick the I. So therefore that will give us tan inverse of 1 over 2. So we'll just get to punch this on the calculator, then whatever that we get to find is the answer. Okay, be following here. Are we moving together? Right. So how do you get to add and subtract complex numbers? Let's say you have got z1, which is equal to 4 minus 3i, and then we have got z2, which is less than negative 2 plus 4i. Now the question we have for the first one, we want to find z1 minus z2. The next one, let's say we want to find z1 plus 3z2. You want to work out this. So basically to find a z1 minus z2, just get z1, which is 4 minus 3i, and then minus z2. Now put z2 in brackets, alright? That will be negative 2 plus 4i. So you need to put it in brackets, because if you don't, it is going to mean something different. So this is going to give us 4 minus 3i. We distribute now the negative. Negative times negative 2i, that will be positive 2. I mean negative times just negative 2. Negative times negative 4i, positive 4i, that will be negative 4i. And then now add like terms. 4 plus 2 is 6. Negative 3i minus 4i, that will be negative 7i. So this is how you get to work out this complex number, just direct as that. So also want to work out z1 plus 3z2. So write z1, which is 4 minus 3i, and then plus 3. Now we write z2, which is negative 2 plus 4i. So this will be 4 minus 3i. 3 times negative 2, that will be negative 6. 3 times positive 4i, that is going to be 12i. Add like terms. 4 minus 6, negative 2. Negative 3i plus 12i, positive 9i. So that is basically how you get to add, subtract complex numbers. Do we have questions? Are we good? Okay. Yeah, there is noise. Okay. Now, when you've been given a complex number z, which is equal to, let's say, 4 minus 3i, we are able to conjugate this, right? To conjugate means to do away with the imaginary part. So you can multiply by the conjugate. The conjugate of a complex number is represented by z with a bar on top. Now the conjugate of a complex number, what you do is you change the sign of the imaginary part. Please, you change the sign of the imaginary part. So that is going to be 4 plus 3i. So you can as well find z1, I mean z times z bar. So z times its conjugate, that will be 4 minus 3i multiplied by 4 plus 3i. Just like we are able to see here, this is the difference of two squares, because we can see the only thing that is different is the sign on the middle. So just like we know, when you're multiplying a number by its conjugate, or the product of two difference of two squares, just get the first one, you square it. Always put a minus on the middle, always. Then get the second one, you square it. So this will give you 4 squared minus 3 squared, now also I squared. So it's supposed to be 3 squared I squared when we distribute that square. Now we know that I squared is a negative 1. This is something that you need to know about complex numbers. I squared is equal to a negative 1. So this will make it negative 1 here. This negative times this negative will give you a positive. So you are going to have 4 squared plus 3 squared. So basically what I wanted you to notice is that whenever you multiply a complex number by its conjugate, just get the first number, you square it, get the number in front of the I, you also square it, but always put a plus at on the middle. Please always put a plus. Don't include the I. Just get the number in front and always put a plus. Always. Right? So this is going to be 4 squared. 16 plus 9 squared should be a 25. So that is going to be it. So another thing that we're able to find from here is first let me see. Are we okay? Right. Yes. Yes. Right. Yes, Esther. Okay. Okay, well, let's consider that. Let's say we've been given z1 to be negative 3I plus 4. We want to conjugate or to multiply by the conjugate. What will be the conjugate of this one? So the conjugate, which we can write as z1 with a bar on top, always change the sign of the number that is imaginary. So this is going to be positive 3I plus 4. It's not like SADS where you change the sign on the middle. This one you always change the sign of the imaginary part. Right? So still z1 multiplied by z1 bar is going to be negative 3I plus 4 multiplied by positive 3I plus 4. Every time you multiply a complex number by its conjugate, just get the first one, that's negative 3, alright? You square it. Plus the 4, you square it. So you always put a plus here. Always put a plus. It doesn't matter whether I get a negative or I get a positive. The thing is I'm squaring, so the answer is going to be the same, but always make sure that there is a plus, right? So it's going to be still 9 plus 16, which is still a 25. We are good? Alright. So all this problem came about for equations like this. When you have got x squared minus 4 is equal to 0. To solve such an equation, we're going to take for the other side, so we're going to have x squared is equal to 4. And here to remain with x, you have to square root both sides. So x is going to be square root of 4. And you know that is going to give you positive or negative 2. Now when you have got an equation like x squared plus 4 is equal to 0. This will give you x squared is equal to, take for the other side, negative 4. So x is supposed to give you the square root negative 4. But you don't have the square root of a negative number. So that is why complex numbers get to be important. So you can actually write this as, we already did that, so negative 4 is the same as 4 times negative 1. So here we're going to have x being equal to square root of 4 square root of negative 1. We know square root of 4 is positive or negative 2, but square root of negative 1 is I. So this is where the principle comes in. Okay? So this is where it comes in. This is where complex numbers become very, very important. So So from here we can write that square root of negative 1 is equal to I. It's from here that everything else is going to come from. Are we okay? Okay. So if I square both sides, I square both sides of this equation, we are going to have this squared and this squared. So that will give us I squared. I've started by writing this one, and that is going to be equal to the square and the root will go. We're going to remain with negative 1. So I squared is equal to negative 1. So I'm going to start from there. That is something that is very, very important. Okay. So I squared is equal to negative 1. It's from here that I want to derive something very, very important. So I want you to pay attention. I'm going to multiply everything by I. So I squared times I, we are going to have I to the power 3. Negative 1 times I, we are going to have negative I. And then I'm going to multiply again. I to the power 3 times I, we are going to have I to the power 4. Negative I times I, we are going to have negative I squared. But remember what I squared is. So we're going to have negative. Where there is I squared, I'll put negative 1 because negative I squared means negative 1. So meaning that negative I squared is the same as positive 1. I hope we are following that. And then I multiply by I, we have I to the power 5. We multiply 1 times I, we are going to have I. Now, sorry it can't show. I'll wait for a bit. So, I don't know if you people are able to understand what I've written here since it wasn't able to show. Is it okay or I need to re-explain? Do I need to explain? Okay. So I first wrote I squared is equal to 1. I multiplied I squared by I got I to the power 3. I multiply negative 1 times I get negative I. And I again multiply by I this. Okay, I to the power 3 times I, it gives us I to the power 4. And then negative I times I, it will give us negative I squared. But remember, negative I squared itself is negative 1. So I'll replace where there was I squared with negative 1. So that will give us positive 1. And then I'll multiply again by I to the power 4 times I to be I to the power 5. And then 1 times I, it will be I. Is that okay now? And then again I'm going to multiply by I to the power 5 times I, that will give us I to the power 6. And then this I times I, it will give us I squared. But remember I squared is what? Negative 1. I'll multiply again by I. Okay, I to the power 6 times I, that will be I to the power 7. Negative 1 times I, that will be negative I. I'll multiply again by I, that will be I to the power 7 times I, that will be I to the power 8. And then negative I times I, that will be negative I squared, which is the same as positive 1. Right? Again, I'll multiply by I, that will give us I to the power 9. And then 1 times I also, that will be I. I'll again multiply by I to the power 9 times I, that will be I to the power 10. And then I times I, that will be I squared, which is negative 1. Are we good so far? Are we good? Are we good so far? Now I want you to get this because they are going to give you bigger powers for you to work out and you can't continue doing this. So I want to derive an equation that is going to apply for all of them. So you can see this one is giving us negative 1. I'll go to another negative 1. Also this one is negative 1. Even this one is negative 1. So you can see those giving us negative 1, we have got I to the power 2. We have got I to the power 6. We have got I to the power 10. All of these are giving us negative 1. So I want you to realize what the trend is. So to the power 2, what do you think we are adding to for us to get to the power 6? And then from that we get to the power 10. What do you think we are adding to the power 2? What do you think is being added there? We are adding a 4. Very good. So that means that we can derive an equation to say I to the power 2 plus 4. Now instead of it just being 4, we are going to say 4n. Okay, where n is a number, is an integer, so it can be 0. So if n is 0, we are just going to have I to the power 2. It will give us negative 1. If n is 1, it will be I to the power 6. It will give us negative 1. If n is 2, 4 times 2 is 8 plus 2, that will be 10. I to the power 10 will give us negative 1. So I to the power 2 plus 4n is equal to negative 1. This is a general expression that we can derive. Alright? We have derived. And then we go to those giving us negative I. We have got this one. We also have this one. We can see we are starting from power 3. And then we go to the power 7. So we can say I to the power 3. For us to move from 3 to 7, we are adding what? 4. So I also say 4n. It is giving us negative 1. This is a general trend that we are able to get. We go to those with power 4. We can see from 4 we are going to what? To 8. It is giving us a 1, alright? So I'm going to say I to the power 4. For us to move from 4 to 8, what are we doing? We are adding a 4. So I'm going to say plus 4n. Okay? If I don't want to say I to the power 4 plus 4, I can also say it is I to the power 4. For me to move from 4 to 8, what am I doing? I'm multiplying a 2. Okay? So I'm going to say I to the power 4n. So that when n is 0, we are going to have I to the power 0, which is, of course, we know that any number is to the power 0, the answer is what? Is 1. And then if n is 1, that will be I to the power 4, which we can see is still 1. If n is 2, that will be 4 times 2, which is 8. We can see I to the power 8 is still 1. So that gives us a general trend. Is this okay? Is that okay? I don't know if we are confused or we are together since we are not answering. Best, are we okay? Pardon? Esther? Yes, Esther? You will see when we use them. What I want you to understand is how I'm getting them. Have you understood how we have gotten them? Okay, the last equation we are going to have is when we have got I to the power 5. I to the power 5 is giving us I. Even I to the power 9 is giving us I. So you can see when we have got I to the power 5, for us to go to power 9, we are adding a 4. So instead of just a 4, it can be 4n, like it can be anything, n can be anything, any integer. So that will give us I always. So this is a general trend that we can get. Now, how do you apply this? Let me write this side so that you see when we apply them. I to the power 2 plus 4n is equal to negative 1. Then we have got I to the power 3 plus 4n is equal to negative I. Then we have got I to the power 4 plus 4n, or we can say I to the power 4n. This is giving us positive 1. And we have got I to the power 5 plus 4n. This is giving us I. Now, how do we apply them? I've seen questions in the exam which say express the following in the form a plus ib. So I've got I to the power 200. They want you to express it in the form a plus ib. In other words, you don't want to have I to the power 200. You just want to have I. You want to simplify that. So how can you do that? So this is when this becomes very important. So what we are going to do is we are going to be using these same powers that we are able to see. Now first you can see that 200, so 200 can be expressed in any of these forms. You can't express them in all of the four forms. It's only one. Okay, now since 200 is an even number, I'm going to look at even numbers. So 3 is not even, 5 is not even, meaning that I to the power 200, I can either express it in this form or in this form, right? I can start the first one. I'll say I to the power 200 is equal to I to the power 2 plus 4n. I need to make sure that I find n to be an integer, a whole number, not a fraction. So I'm going to equate the powers since the bases are the same. So say 200 is the same, is equal to 2 plus 4n. I'll take to the other side, that will give us 198. That will be equal to 4n. So for me to remain with n, we'll divide both sides by 4. Now 4 can't go into 198 without leaving a remainder, meaning that this is not okay. It's not possible. So I can go for this one. I try to express. I'll say I to the power 200 is equal to I can either say 4 plus 4n, or I can say I to the power 4n. So since the bases are the same, we equate the power. So 200 is equal to 4n. Divide both sides by 4. N is going to give us 50. And this is an integer, you see, it's an integer. Meaning that I to the power 200 is the same as I to the power 4n. And remember, anything that can be written to the power 4n is equal to 1. Meaning that I to the power 200 is the same as 1 in the form a plus ib. Okay, we have expressed it in the form a plus ib. It's just that for the a plus ib, for this one we don't have the imaginary part. That is why you can only see the a, which is the 1. So that is how you are able to express this. Is this okay? Okay. So you are going to find questions like uh, evaluate I to the power negative 7. You want to evaluate I to the power negative 7 in simplest form. So you can say 7 is an even number, right? It's an odd number. So you can, the priorities I'm going to pick is either this one or this one. So I'll say let I to the power negative 7 be equal to, let's say, I to the power 3 plus 4n. So I'll equate the powers. Negative 7 is equal to 3 plus 4n. I'll take 3 the other side. So it will be what? Negative 10. That will be equal to 4n. We know 4 can't go into 10. That means that it's not possible. It can't be that one. Right? I'm going to try the other one. I to the power 5 plus 4n is equal to I to the power negative 7. So this is going to be 5 plus 4n is equal to negative 7. I'll take 5 the other side. So 4n is going to be equal to negative 7 minus 5 if it goes the other side. That is going to give us what? Negative 12. Divide both sides by 4. N is going to be negative 3. And we can say that 3 is an integer. Meaning that I to the power negative 7 can be written in this form. And we know that every time we have got this form, the answer is always equal to I. Meaning that I to the power negative 7 is the same as I. We are good? Esther, I didn't get you. Okay. Best, are we okay? All right. So that is it about that one. So let me get back again to the conjugating. So we also have what we call the modulus of a complex number. Now modulus, if you have been given a complex number z, you are going to see it in these brackets. This is called the modulus of that complex number. Okay? So if you have got z, which is equal to 2 plus 4i, and you want to find its modulus, so that will be z with a bar. That will simply be equal to 2 plus 4i in bars. The modulus, just get the first number, you square it, plus the number in front of the I. Don't get the I. You square it, and then you square root. That will be the modulus. That is going to be square root of 4. 2 squared is 4. 4 squared is 16. That is going to be what? Is it a 20? And you know that 20 is the same as 4 times 5. Square root of 4 is 2. So this is going to be 2 square root of 5. So this is the modulus of this complex number z. So the modulus is simply the absolute value or the length of that complex number. Now, when you have got a complex number z, you multiply it by its conjugate, you find that the answer is going to be the same as you get z, you find its modulus. Let's hope this is the principle that I'm applying. Okay. So at times you are going to say such a question to say prove that this is equal. So let's say we have got a complex number z which is equal to 4 plus 3i, right? This is what we have. Is this the same principle or not? Okay, z1, let me give it differently. Let's hope I wasn't proving a wrong thing. Let's say we have been given z1 as 4 minus 3i. We have been given z2 as, let's say, 2 plus 3i. And then the first question we've been asked is to find z1 multiplied by z2. Okay, and then let me say by the conjugate of z2. Then the next question we've been asked to find is z1 z2 with a bar on top, like that. Okay, the next question we can find, let's find z1 conjugate multiplied by z2 conjugate. We show if it is going to be equal to z1 z2. This is the principle I wanted to talk about. This, we see what it means. So let's start with z1 times the conjugate of z2. So for a, z1 is 4 minus 3i. We want to multiply by the conjugate of z2. The conjugate of z2, we need to change the sign on the middle. That will be negative 3i. So start multiplying. 4 times 2, that is going to be 8. 4 times negative 2, that will be negative 12i. And then negative 3i times 2, negative 6i. Negative 3i times negative 3i, that will be positive 9, right? And then the I is going to be squared, isn't it? Because we have got i's. This is going to give us 8. Now we know that I squared is negative 1, so that will become negative 9. Okay, minus 12i minus 6i. So what we are doing is we're expressing in the form a plus ib. And sorry that it takes, you can't see now because it's a bit of slow showing. Are we good? Do you have questions before I proceed? Okay. Are we able to see now? I don't know if we couldn't get somewhere. Should I repeat? Okay. So this is the 8 minus 9, which is negative 1. So I only adding like terms, and then negative 12I minus 6y, which is negative 89. So that is Z for the first part. And then for B, we want to find Z1, Z2 with a bar on top. Alright? Z1, Z2 with a bar on top. So what that means is that you are going to get Z1 itself, you multiply with Z2, and then the final answer you find its conjugate. You can see that the bar is coming from Z1 up to Z2. I hope you can get that. So I'm going to get Z1 first, multiply with Z2. Okay? And that is going to give us Z1 is 4 minus 3I, Z2 is 2 plus 3I. Start crossing and multiplying. 4 times 2 is 8. 4 times 3I is 12I. Negative 3I times 2, negative 6I. Negative 3I times z, positive 3I, that will be negative 9 with I squared. But you know I squared means negative 1. So it will make this 9 to be positive 9, which will come here. And then plus 12I minus 6I. So this will give us 17 plus, that will be plus what? 6I. So this is Z1 times Z2. So to find what we want, that is Z1 times Z2 with a bar on top. This is going to be, we just change now the sign of the imaginary part, the part with an I. We change the sign. So that is going to be the answer there. Are we okay? Okay. Now let's work out C. We want to prove that Z1 conjugate, Z2 conjugate is equal to the conjugate when you just multiply direct Z1 and Z2. So I think you've already seen how I have worked out Z1, Z2 with a conjugate on top on both of them. Now let's find Z1 conjugate and multiply to a Z2 conjugate. So Z1 conjugate times Z2 conjugate is going to be Z1 is 4 minus 3I. But you want its conjugate, so the sign changes to positive. Please, even if this thing was this side, you only change the sign of the thing with an I. So don't never change the constant, the sign, even if it is the other side. Best, you have got a question? Okay. So you've seen also for Z2 I've changed the sign on the middle to negative because I also want the conjugate of Z2. Now let's multiply. 4 times 2 is 8. 4 times negative 3 is negative 12I. Positive 3I times 2 is 6I. And then positive 3I times negative 3I, that will be negative 9I squared. We know this is going to give us positive 9, right? Positive 9 plus 8, that is going to be 17, isn't it? And then negative 12 plus 6, we know that is going to give us negative 6i. So you can see that what we have found is z1 bar, z2 bar is actually equal to z1, z2 with a bar. And this question is mostly likely to come in your quiz 1. Like they like bringing this question. So take note. If you multiply two conjugates, it's the same as multiplying those without conjugates, and then the final answer you conjugate it. Are we okay? Are we okay? O- Okay, let me look at the last example. Let's say they've asked you to they've given that the z, which is equal to uh, let's say 4 minus 3i divided by 3i plus 2 squared. They say express z in the form a plus ib. That's the question. Express z in the form a plus ib. So how can you do it? So the first thing that you have to do is to make sure that the denominator, you don't have those brackets, okay? So this is the same as 4 minus 3i divided by. I've always been talking about this. When you have got two terms in brackets with a square, get the first one, you square it. So get this one, you square it. If you want, write it twice and then you start crossing and multiplying. So get the 3i, you square it. That will give you 3i squared. And then get the